Hi, now that we've talked about prisms, let's talk about cones. A cone is a solid object that tapers from a flat base on the bottom to a single point at the top. Sounds a little complicated, easier than it sounds. The volume of a cone is exactly 1/3 the volume of a prism with the same base and height. What are we talking about? The standard cone, that people call cones, has a flat base that is a circle and it tapers up to a single point. Another cone that would be called a square base cone, often called a square-based pyramid, has a square base for a bottom and it tapers up to a point. You could have a rectangular base pyramid, which went up like that. You could have a triangular base pyramid. You could have all kinds of things. Anyway, the cool thing is that you can remember the formulas for all of these just by remembering that it's 1/3 of the equivalent prism. So what have we got? Here, the base radius is r and the height is some h. Here we have, it's a square base, so it's a side and a height. Here we have a length and a width and a height. Now, if we were talking about a cylinder, the volume would be pi r squared h. That is the area of the base times the height. But for the volume of a cone, it's 1/3 of that. What is the volume of, if this was a box with a height of h and bottom sides of s and s, then the volume would be s squared times the height. And the cone, the pyramid, whatever you want to call it, has a volume of 1/3 of that. Normally a prism that would be a box would have a length times width times height, but if it tapers up to a point, it's 1/3 length times width times height. And let's do a couple of examples. If you had a cone that was, let's say, 8 inches across and 12 inches tall, then, well, the base radius is really 4 inches because I gave you the diameter, and so the volume would be 1/3 pi r squared, which is 4 squared times the height of 12. And so what is this? This is 1/3 of pi times 16 times 12. And the volume, because the measurements are in inches, will be cubic inches. Let's see, 1/3 of 12 is 4. 4 times 16 is 64. 64 pi inches cubed, and if you want to know what that is exactly, you take 64 and you multiply by pi, and you get a little over 200. 201. This is approximately 201 cubic inches. If you had a trapezoidal base prism, something like this, and it all goes up to a point, you'd say, well, let's say the height is, 30 centimeters, and across here is going to be 15 centimeters, and across the back is going to be 35 centimeters, and this distance from here to here is going to be 7 centimeters. Then the volume is going to be 1/3 of the equivalent trapezoidal prism. 1/3 area of base, and the area of base is 1/2 15 plus 35 times 7 times the height, the actual height, 30 centimeters. Well, it's not. If I'm going to use units, I have to remember that it's going to be cubic centimeters. And what is this? 15 plus 35 is 50. So 1/2 times 1/3 is 1/6 of 50 times 7 times 30 cubic centimeters. The 1/6 cancels with the 30, leaving behind 5. And oh goodness, this is what? 7 times 250 cubic centimeters. If you leave the 7, 5 times 50 is 250. 7 quarters is $1.75, so this is 175.0 cubic centimeters. So there's some examples.